Okay, guys. So network and I'm like marking. So ashna mark means I will simply teach and then um it it a video. Okay, so I will upload the video afterwards, and you guys will just learn from the video. Okay, so in um a typically without a rate of reaction, rate of reaction, rate of reaction. So ka rate of reaction hi fane ya tsundzuka definition ya rate. Isn't that now you revise aner? So rate, this the rate of change, the rate of change in concentration of reactants or products. Okay, so rate of reaction is the rate of change in concentration of reactants of products. Therefore, rate is equals to change in concentration divided by change in time. Okay, according to this definition, it means rate is equals to change in concentration divided by change in time. Okay, so that is how we calculate rate using this equation. But you guys, you need to remember kuri rate ya yina ti-units ta ku hambanahambana. Okay, ti-units ta rate a hi tin'we. Swa endleka minkarhi yin'wana va ku calculate your rate in mole per second, va ku ya calculate rate in mole per second. Lexi yimela number of moles and then lexi yimela time, ne? So negative loyi just wo hi kombisa swa ku hi yo divide hi wo nkarhi. Okay, so loko u calculate rate va ku va yi lava in mole per second, u ta ku rate is equals to change in number of moles divided by change in time. Okay, so it will change in number of moles divided by change in time. Loko va ku va lava rate away in what? In mole per second. So vula swa ku hi ta ku rate is equals to change in number of moles divided by change in time. What about loko va ku va yi lava in grams per second? Loko va ku va yi lava in grams per second, hi ta vuya hi ku okay, rate is equals to change in mass divided by change in time. Why? Because grams is mass and then S is delta T. It divide mass is delta T. I mean, it divide mass is delta T. This is why a formula equal rate is equals to change in mass divided by change in time. Okay. So loko vo va lava rate in decimeter cubic decimeter divided by or va ku per second. So loko va hi nyika leswi rate ya wena va ku nyika ti-units leti va ku va lava swa ku yi va in this units, swi vula swa ku u ta ku rate ya mehe is equals to change in volume divided by change in time. Why? Because cubic decimeter it units ta volume and then leswi it units ta yini ta nkarhi. Okay, so that's how we calculate rate. Depending ka ti-units leti vo va ngo hi calculate rate ya hi toho. so hi ta tirhisa ngopfu ti-units leti va ngo hi calculator rate hi toho. Okay, now sure, because now we are just doing revision, ma swi tiva swa ku na ti factors that affect the rate of reaction. Factors that affect the rate of reaction. Ya swi tiva swa ku factor number 1 leyi affectaka rate of reaction is a catalyst. It's a catalyst. And then factor number 2, we have temperature. Remember, temperature can also affect the rate of reaction. And then number 3, we have concentration. And then number 4, we have surface area. Remember, surface area is also what we call state of division. State of division ka rio surface area wena. State of division is either maybe powder kumbe kuva ti granules. Okay, so loko hi khuluma state of division hla swa ku xilo is either xi le ka powder kumbe xi le ka kumbe xi le ka ti granules. And ya swi tiva loko hi le ka powder swi ngo hi na large surface area. Loko surface area hi ri large, and then loko hi na ti granules swi vula swa ku hi na small surface area. Surface area hi va yi ri small, but loko yi ri powder hi va hi na large surface area. Ya swi tiva swoleswo. Okay, now so again hi fane hi understand timhaka ta Maxwell-Boltzmann distributive curves. Hi na le ya temperature, Maxwell Boltzmann curves. Ka ti Maxwell-Boltzmann curves, remember hi na le ya temperature, hale hi va na kinetic energy. So the graph leti just u fane u ti tiva ne. So hale hi va na number of particles. Sweswi hi khuluma hi ya temperature, loko ku cinca temperature ne. So ya temperature swi tiva swa ku before temperature yi cinca, loko yo va hi ri na graph so hi ta ku i mani i T1. Okay, mara loko temperature yo increase, graph hi shifta ya ka left, ya ka right. Graph hi shifta ya ka right, so hi hetelela hi va na swilo leswi. Leyi ta ku i T2. Ya yi vona musi swa ku humela yini i curve ya hina yi shifta ya ka mani, yi shifta ya ka right loko temperature yi ma kanjhani yi tlakuka. So here T2 is greater than T1. Okay, so this is what we call Maxwell-Boltzmann. Se hi swi tiva T1 i temperature leyitsongo, T2 i temperature loko yi ma kanjhani, loko yi increasile. Okay, and then hi na ya concentration. So ka concentration, loko ku ri na ku cinca ka concentration, hi va hi ri na graph ya so ka Maxwell-Boltzmann kinetic energy. Kinetic energy and the number of molecules. Okay, so loko before yi increase our concentration, loko yo va hi ri na graph ya so, ku ya humelela yini loko yi increase concentration? Loko yi increase ka concentration, graph ya kwini ya henhla ka the original one. Okay, because concentration, remember, if I'm saying number of moles, which is also related to the number of particles. The number of particles like my y-axis, that's why it to increase. Local concentration increase. Na to different manganjani increase. So graph away lands to number of molecules ya henhla. Okay, so graph hi ta henhla loko hi ri na yini, hi ri na Maxwell Boltzmann distributive curve yi ta hi nyika e curve ya ku ringana leya. So la ka point leyi la ka point la hi laha hi nga na activation energy is the same na la hi ta va hi ri na yini activation energy. Okay, so la ka part liya hi ta ku hi na activation energy. Okay, hi la activation energy ya hi nga kona. All right, so let's say va hi nyika swilo swa ku fana na leswi, va hi nyika swilo swa ku fana na leswiya laha. Okay, va ku okay ku na ma experiment la, hi na ma experiment 1 na experiment 2. Va ku okay ka experiment 1 hi ta va na concentration leyi nga measure-riwa, hi ta va na state of division, hi ta va na state of division, and then hi va na time in seconds. Okay, so okay la ka concentration, by the way, in mole per cubic decimeter, that is your concentration. Okay, ka concentration ya ku sungula ka experiment number 1, concentration ya yi ri 0.1, and then ka experiment number 2 again 0.1, and then la va ka experiment number 1 va rhange va tirhisa yini powder, ka number 2 va tirhisa granules, and then loko va tirhisa powder, nkarhi lowu nga hela loko hi endla experiment leyi is 25 seconds, and then la loko va tirhisa ma granules swi swa hi tekela about 40 seconds. Now va nga ha ku vutisa va ka we, which reaction was faster, hi le ka experiment 1 kumbe experiment number 2? Well, u nga buka nkarhi la, lowu nkarhi i 25, lowu nkarhi i 40. Loko vo hi tsutsuma marathon, hi tsutsuma un'wana a fika elayinini 25 seconds, un'wana a fika hi 40, obvious loyi a nga fast loyi a nga fika hi 25 hi ku hatla fika ne. So the reaction that is faster i experiment number 1. So reaction leyi nga ta va yi ri faster i experiment 1. So the faster reaction hi leyi nga le ka experiment number 1. Okay, because I vona yi teke nkarhi wutsongo, yi teke 25. Leyi is slow because yi teke nkarhi wa ku tala, yi teke 40. Okay, and then ma nga ha ku vutisa ku which one is your independent variable. So loko va hi vutisa independent variable, remember independent variable hi khuluma hi variable leyi cincaka, is the changing one, the changing variable leyi nga faneki, so yi fane yi va not the same, is not the same, ya cinca, is changing. Okay, and if we check here, concentration is the same, state of division is not the same. Can we see that? Powder, granules. So swi vula swa ku independent variable la yi ta va yini, yi ta va state of division, state of division. So your state of division your independent variable, and then loko va ku va lava controlled variable, control variable leyi nga the same, in other words is not changing, that is the controlled variable, the one that is not changing is the same. If you check here, you can see concentration is the same, it's not changing. So control variable ta ku yini I concentration. Concentration is your controlled variable. And then your dependent variable, remember, this is rate of reaction. And we are changing this variable so that we can check the rate at which the reaction progresses. So hi cinca ti-variables leti hinkwato swa ku hi ta kota ku vona rate of reaction swa ku yi cinca njhani loko hi cinca ti-variables, which means dependent variable yi ta tshama is always what? Is always rate of reaction. Dependent variable always ta tshama ku ri rate of reaction, because all these variables are changed so that we can check the what? The rate of reaction. That's why dependent variable always yi ta tshama yi ri rate of reaction. So loko va ka we explain using collision theory. Explain using collision theory. Explain using collision theory why reaction 1 is faster. So we are going to be explaining using the collision theory why reaction 1 is faster. Now, which variable was changed in reaction 1? Loko la ku explain a collision theory swa ku why reaction yin'we yi va fast, always cheka variable leyi nga le ku cinceni. The variable that is changing there, remember, is the state of division, which is the what? The surface area. The surface area. Swi vula swa ku loko hi explain hi tirhisa yini? Hi tirhisa a surface area. Okay. Now, ka surface area, remember, loko explain how to tirhisa surface area, the first bullet we are going to say more particles are exposed. Loko as I increase the surface area, remember ka reaction 1 we have powder, which means now more particles are exposed. Number 2, it avuya hi ku more particles collide. They collide with correct orientation. More particles collide with correct orientation. Number 3, more effective collisions per unit time. More effective collisions per unit time. And then rate of reaction increases. Okay, let's tsala ka swo always loko hi explain a collision theory ya surface area. Okay, and then va nga hi vutisa va ku hi calculator kumbe va hi kombela swa calculator rate of reaction. Hi calculator rate of reaction in mole per cubic decimeter, per second. Mole per cubic decimeter ya swi tiva I concentration and second is time. So vula swa ku hi teka concentration yi divide hi time. So ni ta vuya ni ku rate is equals to change in concentration divided by change in time. So loko yo va hi ri le ka reaction 1, ni ta vuya ni ku okay, ka reaction 1, what is my concentration? In reaction 1, my concentration is 0.1. So I'll say 0.1 divide by, what is the time? The time is 25 seconds. It means I will divide by 25 seconds. So you'll punch 0.1 divided by 25 seconds, and then you get a particular number. I do not have a calculator here to punch it, but of course you'll get a number. But ti-units leta va nga ku nyika hi toho va te in mole per cubic decimeter per second. U tlhela u tsala toho futhi le ka answer ra wena. In mole per cubic decimeter per second. And then u ta ku answer ra wena in mole per cubic decimeter per second. That will be your rate of reaction in experiment number 1. According to leswi va yi lavisaka swo hi ti-units leti. Va lava concentration u yi divide hi nkarhi. Okay, I hope swi endla essence.